Have you ever looked up at a helicopter and thought, how is that thing not falling out of the sky right now? I mean, seriously, airplanes make sense. They have wings, they go fast, air flows over the wings, boom, they fly. But helicopters, they're basically a metal box with spinning blades on top, defying every instinct we have about what should and shouldn't be able to fly. Here's the thing though, according to the laws of physics, helicopters shouldn't just be difficult to fly, they should be absolutely impossible. And yet, there's one flying over your head right now, probably carrying someone to a hospital or reporting on traffic. So, what's going on here? How do these mechanical marvels cheat the laws of nature? And why do pilots have a saying that helicopters don't fly, they beat the air into submission? Today, we're going to uncover the beautiful, chaotic science behind why helicopters are basically flying contradictions that somehow work anyway. Let's start with the biggest problem: Newton's third law. For every action, there's an equal and opposite reaction. So when those massive rotor blades spin clockwise at 400 RPM, Newton says the helicopter body should spin counterclockwise. Imagine trying to fly while your entire aircraft is doing pirouettes in the sky. But wait, it gets worse. Those rotor blades aren't just spinning, they're also trying to tear themselves apart. At the tips, helicopter blades are moving at nearly 500 miles per hour. The centrifugal force is so intense that without proper engineering, those blades would literally rip off and become flying projectiles of death. And here's the kicker. Unlike airplane wings that have nice, steady airflow, helicopter blades are constantly changing their angle and speed as they rotate. The blade moving forward into the wind experiences completely different forces than the blade moving backward. This creates something called dissymmetry of lift. Basically, one side of your helicopter wants to fly higher than the other side. It's like trying to balance on a seesaw while someone keeps moving the fulcrum. So how do helicopters solve these seemingly impossible problems with some of the most elegant engineering tricks ever devised? First, that spinning problem. Engineers added a tail rotor, a smaller propeller that pushes sideways against the helicopter's body. It's like having a friend constantly pushing against you to keep you from spinning around. Simple but brilliant. But some helicopters don't even need tail rotors. The Chinook has two main rotors spinning in opposite directions, so they cancel each other out. It's like having two people spinning you in opposite directions. You stay put. Now, about those blades trying to rip themselves apart, engineers created something called a Jesus nut. Yes, that's the actual technical term because if it fails, you're going to meet Jesus. This massive bolt holds everything together, but the real magic happens in how the blades are attached. They're not rigid. They can flap up and down, lead and lag back and forth, and even twist their pitch. This flexibility is what solves the dissymmetry of lift problem. When the advancing blade generates too much lift, it automatically flaps up, reducing its angle of attack. When the retreating blade generates too little lift, it flaps down, increasing its angle. The helicopter essentially adjusts itself automatically. It's like the helicopter is constantly doing yoga, bending and flexing to maintain balance. But here's where it gets really wild. Flying a helicopter requires controlling four different things simultaneously: the collective, up and down; the cyclic, forward, back, left, right; the pedals, rotation; and the throttle, power. It's like trying to pat your head, rub your stomach, hop on one foot, and solve a math problem all at the same time. Except if you mess up, you crash. And unlike airplanes, helicopters are inherently unstable. An airplane wants to fly straight and level. It's naturally stable. A helicopter is like balancing a pencil on your finger while riding a unicycle. It requires constant, tiny corrections to stay in the air. This is why helicopter pilots train for years just to hover in one spot. Something that looks effortless is actually an incredibly complex dance of physics, engineering, and human skill. But here's the most mind-blowing part. If the engine fails, helicopters can actually glide to safety using something called auto-rotation. The falling helicopter pushes air up through the rotors, keeping them spinning, which provides just enough lift for a controlled crash landing. It's like falling with style, except the style might save your life. So, the next time you see a helicopter, remember, you're not just looking at a flying machine. You're looking at humanity's impressive prank to the laws of physics. These incredible machines shouldn't work according to everything we know about flight, stability, and common sense. They're too complex, too unstable, and too chaotic. But through brilliant engineering, incredible pilot skill, and a healthy dose of controlled chaos, helicopters don't just fly, they excel at things airplanes could never dream of doing. They save lives in places no other aircraft can reach, fight fires that would otherwise consume entire forests, and prove that sometimes the most impossible things are just waiting for someone crazy enough to make them work. Because in the end, helicopters teach us something profound about innovation. Sometimes the best solutions don't make sense until they're spinning 400 times per minute above your head, defying gravity and looking absolutely ridiculous while doing it. Thanks for watching. If you enjoyed, please like, share, and subscribe for more everyday wonders simply explained.